Hello, Rabbit Ape.
There's a 1 in 2 billion chance or whatever that retrovirus is going to insert over here. You're saying that it by chance entered in the exact same position. It doesn't make any sense for the retrovirus to enter in the exact same place on both different species. It's a much more plausible explanation that it enters on a given organism. That organism reproduces.
We are talking about a segment of DNA, but instead of saying the segment came from mutation and duplication, we all seem to agree the segment came from a virus. But we never observed the virus. We only observed the DNA. So it seems the virus is almost like a designer, in that we are saying that something came along and put some DNA into our genome. And we believe this because it is a matter of probability. But probability is an interesting thing. Even though it would have been equally improbable for the virus to insert itself anywhere else along that line, the idea that the virus inserted itself at this specific point is what strikes us as improbable. But how can that one outcome be less probable than any of the other outcomes? Here's how it works. There are two different events. One event is the virus inserting itself somewhere. There are about 3 billion possible outcomes for that event. This is the one VenomFangX was thinking about. The other event is the virus inserting itself in the same place where it had previously inserted itself in a different species. There is only one possible outcome for that event. So the same thing happens, but it is two different events. One of the events is highly improbable. The other event is not nearly as improbable. This is the same reason why predicting an outcome in advance makes a difference in probability. If there are a number of equally probable outcomes and we predict that a particular one of those outcomes will happen, we are creating the possibility for a different type of event to take place. To be specific, we are creating the possibility that what occurs will match our prediction. If we had not made a prediction, the possibility of this event taking place would not exist. So predicting an outcome is one way to make it more significant than the other outcomes. But it is not the only way. Clearly, the actual location of the endogenous retrovirus is more significant than other potential locations, even though we did not predict it beforehand. Let's contrast this with the probability experiment you did a while ago. First you rolled some dice, and then...
That when I threw these dice, there was only a 1 in 1,679,616 chance that this was the sequence I would get. How unlikely is that? But it still happened, didn't it?
Probability is not about ascertaining what did happen or what will happen, but what most likely did happen or what most likely will happen. Highly improbable things happen all the time, but that does not take away from the fact that when we do not know what did happen or what will happen, probability tells us where to put our money. And there is a big difference between an improbable outcome and an improbable event. Outcomes are the different ways an event can happen, like different permutations. Improbable outcomes can be forced to happen if an event happens. But improbable events cannot be forced to happen. So when we are trying to ascertain what likely will happen or did happen, the question is not how probable the outcome is. The question is how probable the event is. For instance, if I turn on my faucet, it is highly probable that water will come out. But the exact outcome, which is the order in which the water molecules come out, is highly improbable. But if the event of water coming out happens, then one of the improbable outcomes is forced to happen regardless of how improbable it is. With respect to intelligent design, there are a couple different questions. There is the raw probability of an event occurring, which we can argue over, but underlying that question is how significant the probability could potentially be. And the answer to that underlying question is what determines whether or not the determination of the raw probability is of interest to science. And I propose that it is of interest to true science in much the same way as it would be of interest to science if an expedition were sent to Mars and it claimed to have uncovered complex items similar to the artifacts and buildings we find in archaeological digs on Earth. Or in much the same way science concerns itself with determining the intelligence of prehistoric humans by ascertaining whether a given individual rock was manipulated by design. The scientists in this discipline make observations about the rocks, such as the angles of the fractures that have been made on the rock, and it is assumed that the probability of certain angles of fracture occurring in nature is so slim as to invoke an inference of design. This is important because one of the arguments used against inference of design is that design gives up too easily, or in other words, that one person's inability to think of a way that nature could have done something without intelligence merely shows a lack of creativity on their part and does not mean science should give up looking for a natural explanation unrelated to design. And yet, in this well-accepted discipline which distinguishes rocks from artifacts, the whole point is to rule out nature based on probability. Consider the words of Carl Sagan in his scientific treatise on the quest for extraterrestrial intelligence, which led to millions of dollars in federal science funding and which his peers seemed to accept pretty well. It is easy to create an interstellar radio message which can be recognized as emanating unambiguously from intelligent beings. A modulated signal comprising the numbers 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, for example, consists exclusively of the first 12 prime numbers, that is, numbers that can be divided only by 1 or by themselves. A signal of this kind, based on a simple mathematical concept, could only have a biological origin. No prior agreement between the transmitting and receiving civilizations, and no precautions against Earth chauvinism are required to make this clear. Such a message would be an announcement or beacon signal, indicating the presence of an advanced civilization, but communicating very little about its nature. Now consider the countless radio sources in the universe. How is it that this radio noise, which Carl Sagan talked about, how would it be scientifically attributable to unknown intelligent beings? What is special about it? Why is it not attributed to nature? Why did Carl Sagan not insist that if we received such radio data, that we should just look for and keep looking for a natural explanation? The answer is that the radio data serves a specialized function, which makes it a different event than the other radio noise. It functions as a set of prime numbers. Nature is not able to select modulated beeps for a function like that, but intelligent designers can. In the absence of a natural means of selection, the odds are simply too improbable against the possibility of design. The greater the number of naturally unselectable parts in the sequence, the less likely it is that the sequence is of natural origin. So it comes down to the existence of a special function, the inability of nature to select for that function, and the number of unselected components which comprise the function. And that is how we would infer design in the scenario Carl Sagan outlined. So we have principles whereby design can be scientifically inferred.